Right, everyone. So this is going to be the continuation for trig. So as much as I did example 1, this is going to be example 2. So I'm going to do A, B for the first lesson and C and D for the second lesson. Right, for the first one we have to solve for theta. So meaning that we have to find the general solution for theta, right? So now the first one we have 2 sine 2 theta equals to 3 cos theta. Now, because cos doesn't have its identity, then you just have to make use of sine 2 theta. So the only identity for 2 sine theta is going to be 2 sine theta cos theta is equals to 3 cos theta. Then you're going to multiply 2 and 2, then you're going to get 4 sine theta cos theta. Then you're going to transpose, right? Because now you can't divide both sides by cos, because now at the end you're going to have 4 over 3, which you have to divide by 0, which is going to be 0. So you just have to transpose minus 3 cos theta is equals to 0. Remember that for your general solution is either you take out the highest common factor or you factorize. That's that. Then from there, the highest common factor that we have for these two terms is going to be cos theta. So you're going to have cos theta, then you're left with only 4 sine theta, then you have minus 3 is equals to 0, right? So meaning that when you solve for x and having to solve this trig equation is going to be cos theta is equals to 0, or 4 sine theta is equals to 3. So you have transposed 3 to the right hand side. Therefore, you're going to divide both sides by 4. Then you're going to have sine theta is equals to 3 over 4, right? Now, it means that we're dealing with two different ratios, right? So meaning that we're going to check the first one, which is cos, and we're going to look at sine. Now, let's check. So now, the ref angle for cos, we know that the ref angle is going to be 90 degrees, right? Then we're going to check where is cos positive on the cast diagram. So this is going to be your cast diagram. Then from there, you know that cos is going to be positive on your first quadrant and your fourth quadrant. So meaning that for your first, it's going to be theta is equals to, now it's going to be 90 plus k multiplied by 360, where k is an element of integers. Then for your fourth quadrant, it means that it's going to be theta is equals to, so this is going to be 360 minus your ref angle, which is 90 degrees, plus k multiplied by 360. K is an element of integers. Then from there, it's going to be 360 minus 90, then you're going to get 270. So this is going to be the solution for cos theta is equals to 0. Then we looking at sine theta now. So we have to look, first we have to identify the ref angle for sine. So therefore we have cos theta is equals to cos, let me just write this one down. So this is 0. Then for this one, it's going to be your ref angle. It's going to be theta is equals to shift sine negative 1, so it's going to be 3 over 4. Then your ref angle, it's going to be, right, shift sine 3 over 4. It's going to be 48.59 degrees. So this is going to be the ref angle of sine. Now we're going to check where is sine positive. Sine is positive, so meaning that according to your cast diagram, so it's going to be your first and second quadrant. So it means that for your first quadrant, we know that theta is equals to, so this is going to be your ref angle of 48.59 plus k multiplied by 360. Sorry, this is going to be 360. K is an element of integers. Then from there, we're going to the second quadrant. So it means that it's going to be 180 minus 48.59 plus k 360, right? And from there you're going to get 131.41 degrees. Then from there it's going to be plus k 360. K is an element of integers, so meaning that this is going to be the general solution whenever we have to solve double or compound angles, right? That's that. So this is for A. Then right, then for B we have 3 sine theta minus cos 2 theta plus 2 is equals to 0, right? Now we know that sine theta doesn't have any identity with it. If it was sine squared theta, then we know that it was going to be 1 minus cos squared theta. But the only ratio that we can change is going to be your double angle of cos 2 theta, right? But now the fact that we have sine, it means that the identity out of the 3 that we're going to choose is going to be the one of 1 minus 2 sine squared, right? Now, so this will be written as 3 sine theta minus into 1 minus 2 sine squared theta plus 2 is equals to 0. Then from there you're going to have 3 sine theta multiply negative 1 and positive 1 is going to give you minus 1. Negative 1 multiplied by negative 2 is going to give you positive 2 sine squared theta plus 2 is equals to 0. Then from there your like terms of negative 1 and 2 is going to give you a positive 1. So if you have to write this in proper order, remember it's going to be in a trinomial form. So it's going to be 2 sine squared theta, then it's going to be plus 3 sine theta, then it's going to be plus 1, right? It's equals to 0. Then if you have to factorize this, then this is going to be 2 sine theta sine theta. Then from there it's going to be your positive and your positive. Then the factors of 1, it's only 1 and 1, right? So meaning that 1 times sine is going to be sine theta, then 2 sine multiplied by 1 is going to be 2 sine theta, then sine and 2 sine theta is going to give us positive 3. Then from there we're just going to solve, so meaning that this is going to be sine theta is equals to minus 1 over 2, or sine theta is equals to minus 1, right? Then from there we're going to check the first one, right? So meaning that we're going to check the ref angle of theta is equals to sine. Remember, ignore the negative sign, so it's going to be 1 over 2. So this is going to give you the 30 degrees. So theta is equals to 30 degrees. And for this one, we know that the ref angle is going to be theta is equals to sine, and this is going to be 1. And we know that 1 is going to be 90 degrees, right? Then from there we're just going to check where is sine negative. So according to your case diagram, it's negative on your third and your fourth quadrant. So meaning that on your third it's going to be theta is equals to, so this is going to be 180 plus, this is going to be 360 minus. So for your third quadrant it's going to be 180 plus the given ref angle, which is 30, then it's going to be plus k 360. K is an element of integer, so then from there this is going to give you 210 plus k 360, right? Then when you go to our fourth quadrant, we know that this is going to be 360 minus the ref angle, which is 30, plus k 360. Then we know that 360 minus 30 is going to give us 330 plus k 360, right? Right, so this is going to be the general solution for sine negative 1 over 2. Then now when we are doing the sine sine of -1. So we know that it's going to be the same thing. So it's still applied to the same quadrant. So it's going to be your third and your fourth. So meaning that it's going to be theta is equals to, so this is going to be 180 plus 90 degrees, right? Then from there it's going to be plus k 360. Then from there we know that 180 plus 90 is going to give us 270. Then from there we go to the fourth quadrant. Then fourth quadrant is going to be 360 minus 90 plus k multiplied by 360. Oh my goodness, sorry. So yeah. So this one was for sine 1, so it's going to be 180 plus ref angle, then 180 plus 90 is 270. Then we're going to the fourth quadrant, so it's going to be 360. So it's going to be 360 minus 90. Then you're going to get 270 plus k. $360. Yeah, then there you go. So there's going to be a ref angle for, a general solution for the equation of 3 sine theta minus cos 2 theta plus 2 cos 2 0. So this is going to be the whole workout for it. So yeah.